Yes, Kevin. So good to go. We can continue.
Thanks, Gaurav. Okay. Hey, everyone. Right. Good evening. My name is Kevin. I will be the trainer for um, the session, right? And this is going to be a demo session for the Palo Alto November batch. Right. So we're just going to take a demo session on different types of interfaces of Palo, right? And in case if you have any questions, right, just feel free to ask, right? Just stop me and just ask if you have a question, right? Okay. So just before I start the topic, right, the idea here is, right, let me just walk you through. Okay, the topic, right? So basically, this is what our curriculum is, what we're going to cover, right, and in a month's time. So this will be a weekday batch, right? Typically around 1 to 2 hours, right? Sometimes it might extend a little bit, right? So ideally 9 to 10 or 11, right? I mean, I think 9 to 11 is what I typically take. So that's how the session will be, Monday to Friday. And we expect to complete it in a month's time, right? And to talk about the curriculum as such, right, we'll start from the very basic to understand how the packet flow happens in the Palo Alto firewall, right? Why is it leading the industry? What is the SP3 architecture of the Palo Alto firewall compared to other vendors? And we'll also go through the packet flow logic, right? Different stages in the life of a packet inside Palo Alto. So from the point it enters to the time it leaves the firewall, what all processing happens to a packet. And some fundamental understanding about what is the management plane, what is the data plane, what is the control plane, right? All of that. Then this ideally would take about 1 or 2 days at least, right, to just cover this basic topic. Why? Because this is the fundamental that is needed to build upon the rest of the stuff, right? And the next part is what I've planned as a demo for today is the introduction to basic interfaces that the Palo Alto firewall supports, different types of interfaces, where it is used, which condition, right? The other next topic is basically about SSL TLS management profile, right? How do you enable admin UI access or blog access on a admin UI or SSH or Telnet on specific data plane interfaces, right? How do you use a custom SSL certificate, right, for let's say Global Protect or decryption purposes, right? How do you call a CA in a certificate profile and use it, right? And we'll also walk through, right, an initial config. So most of the sessions would be lab oriented, right? I mean, initially there are a lot of topics where a lot of theory is involved. So if let's say if we take Global Protect or user ID, right, 1 or 2 days theory would be there, and then we move on to doing a real-time lab. So we'll be deploying this from scratch in the lab, right? For this, and we'll verify how it is configured and how the expected output is. Right. Then we'll talk about HA deployment in Palo Alto. So we'll be deploying active, passive, and testing it, and active will all be covering in a theory aspect as such, right? So that would include all types of HA monitoring, right? Link path monitoring, right? How the what are the different HA timers involved? How the election works, right? All of that. Then moving on, right? Then it's a big topic as such, right? We have to walk through different types of security profiles, right? In Palo Alto, security profiles are basically the heart of the IPS functionality. That means if the administrator wants to control access to certain URLs, applications, or block specific file types, or prevent data loss happening in the network, or they want to make sure that there is no malicious or threat content that is being shared across, right, as a file download or an email attachment, right? How do you make sure that your security policies are airtight, and how to use these profiles, right, in the security policies, which is basically giving the a firewall, the IPS functionality, and the security component is getting added. So this is the heart. Security profile is where all of the magic happens from a security standpoint. So we'll be going through that, right? We'll be doing some demos, testing with URL filtering. Custom URL filtering, right? Your certain features would require license, right? And it's really hard to get a license for Palo Alto Bio because they don't offer any trial as such. So, for example, logging functionality, right? Logs we can only see if we have a license, or URL filtering, for example, right? So there are some limitations from that aspect, but we'll be covering all of the rest. Whatever we can touch, we'll be touching. So this will be a full-blown session of different profiles. How do we use it? And we'll be real-time doing a file block. We'll be trying to do URL block, right? Which is quite easy to do. Moving forward, right? We'll talk about authentication, right? How we can set up authentication in firewall, right? What is the AAA concept, right? How do you integrate your firewall with an external Radius or AttackAxe server or IAM, right? So that would mean SAML authentication, Radius, AttackAxe. How do they get role-based access? That means certain admin might have only read-only access, whereas the other admin might have a super admin access. He can change basically any configuration. So how do you restrict control, right, to different users, right? And if you have different types of authentication, let's say LDAP, Radius, and AttackAxe, how do you combine this together, right? And create an authentication sequence so that the user enters a password, right? It will basically check with all these authentication methods and use the appropriate one, right? So how do an authentication sequence work from that perspective? Then this is, I mean, a little bit fundamental, right? We'll be walking, I mean, some people might not be so familiar with certificates, so we'll have to do a basic of what is a certificate, what is a root CA, what is an intermediate, a leaf certificate, right? And then we'll talk about where certificates will be used in Palo Alto, right? For example, in Global Protect, right, or decryption purposes. How do you create certification profile, right? We'll have to talk about SSL client certificate request. Why do we use it, right? What is the benefit, right? Then certificate chaining, right? So this is a little bit of technology plus the product, right? So little bit. So some of you might already know a very basic idea or have a basic idea of certificates, right? The same needs to be brushed up, right? But we'll be walking through that whole together, right? Okay, then we have to talk about routing, right? So from a routing what we'll do is we'll be playing around with static routes quite often. For this particular session, we'll be setting up a BGP lab scenario, right, with two different locations, and how do we create a BGP neighborships and redistribute routes between eBGP neighborships, right? That is what we are going to demonstrate here, and we'll also talk about PBF, right, which is very critical or important feature that Palo Alto is offering to route the traffic. So it involves a lot of groundwork as well, right? We have to talk about virtual router, right? What is a VSys also we will have to talk about. Not related to this one, but still we have to touch VSys while talking about this as well, right? Then moving on, we have NAT, right? NAT is something is quite often confused, or people get confused in Palo Alto, right? How do you do NATing, right? And if it's a DNAT scenario, how do you set up a NAT policy and security, right? It's complicated. And this is one of the classic questions in the PCNSE exam, right? They'll give you a topology where they'll give a DNAT destination NAT scenario. And they'll ask you to, hey, with an MCQ, you have to select what the NAT policy and security policy should be. So we'll be talking about how the source NAT and DNAT is done. We'll talk about U-turn NAT, right, in same zone and different zone scenarios, right, or hairpin NAT, otherwise known, right? We'll talk about that. This would be an interesting session, but this, right, mostly is a whiteboard session, right, to understand and see how you understand. I mean, this is 90% technology, 10% product, right? So why? Because doing on the product is very easy. It's just that you have to have a technology understanding why we are doing U-turn-NAT or what is this technical challenges associated with it, right? Okay, then going forward, we have IPsec. We'll be doing an IPsec lab by creating IPsec tunnel, sending traffic, right, over two different branches. So we'll be connecting two different branches over the internet using an IPsec and send routing traffic through it, right? Basically giving or establishing access over the internet through the secure tunnel, right? So we'll be doing a real lab on that, and we'll also be taking care of the CLI commands involved, right, to see it, clear it, or test an IPsec P1 or P2 essays. We'll have to talk about proxy ID, or otherwise known as traffic selector, right? And Palo Alto, why? Because this is an important config, as Palo Alto is route-based VPN, purely route-based VPN. So we have to talk about what is a route-based and a policy-based VPN, right? What is the fundamental difference? Why do we need proxy IDs? All of that, right? Then going forward, right? Service route. This is a specific keyword or function that Palo Alto is coming up with. So what is a service route? Why do we use it? And what are the different types of service route that we might use in a daily working scenario for Palo Alto, right? How do you enforce? How do you tell your firewall to connect to your Panorama or to the update server using a different interface, right? All of that will be, and this will, the service route part all will come during our other lab sessions. Why? Because definitely, right, while exporting and all, you might need to play with the service route quite often. Okay, then we will talk about QoS, right? This is not so important from a firewall perspective, because firewall is typically not used to do QoS as such. But the idea here is to basically, right, categorize traffic. So we have 8 classes inside Palo Alto that you can use to mark different traffic. So how does a company ensure that YouTube does not eat up their bandwidth, right? They don't want YouTube to be using the entire bandwidth, and how do we limit it? Maybe let's say 100 or 200 Mbps only for YouTube, right? All of that with QoS profile, right? How do you set a QoS policy to achieve this, right? We'll be talking about the QoS part. Then app ID, right? This pretty much of this will be covered during our initial sessions during life of packet. Why? Because there are some theoretical understanding that we need to have regarding what is an app ID engine in Palo Alto, right? How are these signatures used, right? How does the firewall understand an application, right? How, if you're accessing Facebook, how does the firewall come to know that it is Facebook? Or you're accessing, let's say SMB, right? How does it know about what is the application, right? So this is quite interesting. We'll be taking care of it during the initial sessions itself because it's a basic. All right. I'll take a pause here, right? Any questions up until this point?
No, sir.
Very silent, is it? Okay. All right.
Kevin, sorry.
Yeah, go ahead. Go ahead, Bhaskar.
Yeah, myself, Bhaskar. So actually, what is the base need to learn Palo Alto? I'm a bit confused.
Do you mean what is the prerequisite for this training?
Yes. Like I have networking knowledge. I worked on networking, but I'm not that much confident in networking, routing and switching. I know the concepts as well as I'm not that much.
Okay. So here, right, I mean, see, Palo Alto knowledge is not needed. Why? Because that we are covering from scratch. What is the expectation here is you should have a CCNA level understanding of routing switching, right? That is basic routing switching, that is IP addressing, subnetting, how was an ARP, DHCP, right? All of that you should know. Okay. And the second part is a little bit, right? You should have to come prepared for SSL and IPsec, right? So we will be digging deep during SSL decryption session. Why? Because you should have a clear understanding how the SSL right handshake happens, right? What is the different types of message exchange happening in SSL handshake? That is a prerequisite. I'll take questions. Don't just expect that we'll be covering from scratch. Why? Because that's a technology basic, right? So just do that. It will hardly take maybe 1 hour, right? Just to go through some YouTube videos to come prepared. But the idea is that we will be digging little deep into it, right? Why? Because to talk about decryption, we have to basically extrapolate the handshake and talk about different components involved here, right? So that's the prerequisite SSL part, and the other part is IPsec, right? You should know the 9 messages of IPsec, right? Main mode, quick mode, aggressive mode.
Yes, yes. I have an idea about that also.
Yeah, that is what I would say is a prerequisite for this training. Rest of things we are scratch for. It is from scratch we are starting for Palo Alto, right? This does not mean that you are you don't. We are not expecting you to know about Palo Alto. It's okay if you have not seen the firewall itself. That's fine, right? Rest of things we'll take care.
Thanks.
Cool. Yeah. Any other questions?
Yeah, same thing. I wanted to ask the same question.
Mm-hmm.
So I'm currently working in a data center. My profile is a server admin, but I have no knowledge.
You have when I didn't get that. You have the basic understanding or not?
Yes, I started learning from the YouTube only, for CCNA related. So
Okay.
yes, other than I have no confidence completely. I can't, handle single-handedly of network. So am I, to understand the whole scenario of Palo Alto?
So as I said, right, I mean, if you are good with basic networking, right, that would mean IP addressing, subnetting, right, understanding basic protocols like DNS, DHCP, ARP, right, then that is fine. That is all. The rest of things, right, the security component of how the Palo Alto is working, right, we are going to talk about because this is the next generation firewall, right, compared to other, let's say the older generation, right, Cisco ASA and all, it's not doing any kind of layer 7 inspection. It's just a IP port based firewall. Whereas this one is a layer 7 or a next generation firewall. So we have to talk about how the firewall is identifying this application threat, all of that. So we'll be talking about that.
Okay.
All right. But yeah, I mean, if you're not so confident, I would say just brush up these things, right? We can go ahead. I can assist you, but the key component here is, right, we have to ensure that everybody is going in a steady phase, right, and nobody's lagging as such.
Okay, I will put in a, other than my class.
I didn't get that.
So I will, little brush up outside my class, to
Sure. Yeah,
whatever the.
that would work. Yeah, typically that is what, right. I have seen people who are not directly from security background or who are just switching the technology itself, right? They might be into system admin and they're moving into networking,
Okay.
right? So that's totally
Okay.
fine, right? People catch up. So when there is a need, right, on a daily basis, if you spend 1 or 2 hours extra, right, it is easy to catch up.
Okay, thank you.
Right. Perfect. All right. Any other questions?
Yes, Kevin. Hi, Kevin. Venkatesh here. I'm working as a SD-WAN engineer.
Okay.
Is this module covers like next generation firewall? I think it covers. And what about the remote VPNs?
Yeah, so the remote VPN in Palo Alto is known as Global Protect. Yes, we'll be covering that. Right, we'll be also be doing a lab on that. And the next generation firewall is what we have been talking about, right? The security component, how the firewall is doing layer 7 deep packet inspection on the packets and identifying threat and blocking it. So yes, that is part of it.
Okay. Will you explain about the whiteboard? Like how inside
right,
the Palo Alto?
It will be a whiteboard, right? I mean, just after this, I'm just going to do a whiteboard session, right? So you'll understand how it is done, right?
Oh. Okay, thank you.
Yeah. All right. So just quickly, right, skimming through the curriculum assets, right? So we have to talk about App ID, which we'll be covering in the initial part itself, right? Then we have to talk about the Global Protect or the remote access VPN, right? Similar to Cisco AnyConnect, right? Palo Alto offers something known as a Global Protect. So we have to understand a little bit theory about what is a gateway, what is a portal and all. Then we'll be doing a lab, right, to simulate this and see how it is working, right? Then we'll talk about SSL decryption, right? Forward proxy and right reverse proxy as well. and we'll be doing a lab on this, right? For forward proxy, inbound proxy is very simple, right? Because the only complication involved is we have to have a certificate, set up an internal server to decrypt it. But yeah, forward proxy is a complicated part, which we'll be doing a lab and running up. So all of this involves a whiteboard session. Don't think that it will be right just said as such. No, everything it will be a whiteboard session only. Right? We know that it is difficult to just say, understand by just saying, right? So everything will be whiteboard oriented. Now, moving forward, Palo Alto has something known as the Wildfire solution, right? It comes in 2 flavors, private and public cloud, and it requires an additional licensing. We don't have it, but we'll be going through how it works. How do you configure it, right? What is the benefit that you get, right? So typically, Wildfire is something is like a hot cake in the industry. Why? Because this is giving protection against zero-day exploit. So any kind of unknown virus, right, or a ransomware that is not known, somebody just created it right now, right? Palo Alto Firewall is intelligent enough to flag it off and basically identify it in a matter of minutes, right? So under 15 minutes, it's able to identify it and basically alert all of the firewall. So PA firewalls are intelligent enough, or the threat intelligence data is shared across all the firewalls, and every firewall becomes protected against this new zero-day. So we'll talk deep detail in that aspect as well. Then we have to move to Panorama, right? So the other component of Palo Alto is Panorama, which is nothing but a separate device, right? Which comes in physical or VM form factor. The Panorama is basically used to manage the firewall, right? And receive logs from the firewall, right? And there are some additional functionalities as well. So we'll be going into Panorama, seeing how what are the different components involved there, right? What is a template? What is a device group? Template stack, right? What is a template variable, right? How do you attach a firewall, right? So without licensing, we cannot actually add a firewall to Panorama. So we'll be technically going through what is the exact step involved to add a firewall, right? How would it look like once you add it? Then we need to talk about what are the different types of rules, right? In Panorama, like pre-rules, post-rules, right? Default rules, what is local rules, all of that. And we'll also see, right, the device group, the nesting architecture, right? A lot of new things, I know. So this all will make sense, right, once we start sessions, right, slowly going forward, right? So the Panorama is a most commonly confused product, or people are a little afraid of Panorama. Why? Because, right, not every company own it, but there are openings for right, Palo Alto guys who know Panorama. Why? Because now since people are adapting to Palo Alto more and they're buying more firewalls, for them it is difficult to manage firewalls individually. So they end up buying a Panorama so that they can manage maybe 100 or 500 firewalls together from a single point, right? So it's pretty much similar to the Cisco Firepower Management Center, but a little bit more, or I would say rather more advanced, right? To have a centralized console of managing all the corporate firewalls. So we'll be seeing, right, how different types of licenses, right? How do you take a configuration back? How do you upgrade the firewalls? What are dynamic updates involved, right? What is the Panorama commit recovery feature, right? All of what is the context switch, right? All of that we'll be talking about from a Panorama perspective. And the log forwarding part. How do you set your firewall or tell your firewall to forward all traffic logs or threat logs to the Panorama so that the centralized SOC team can have visibility, right? Sitting at one place, they get the logs from all 100 firewalls. So they would have set it up or monitoring it up, right? And they might be even forwarding it to an external, right, SIEM tool like a QRadar or Splunk server, right, which can generate alerts and tell, hey, right, there was a malicious activity that was flagged, right? So how do you tell your firewall to forward it to external servers or to the Panorama, right? All of that we'll be talking about. Then this is just the update part, right? How do you upgrade a standalone firewall? How do you upgrade an HA pair, right? How do you configure and push changes from a Panorama to a firewall, right? Then the other part is basically to troubleshoot all of this, right? So the last 2 days, typically we'll be going through all of these topics again, just from a troubleshooting perspective. So why? Because in this industry, the main demand is people not to configure, but to troubleshoot problems. Things break. How do you identify what is causing it and how do you fix it. So will be right. Troubleshooting would involve CLI commands, right? Taking packet captures, analyzing it, right? How do you check on GUI, right? Different components. How do you interpret the logs, right? And also a little bit of advanced debugging, right? Which from a CLI will show. So mostly it's CLI based, right? Rest of the component is GUI and little bit of PCAP. So we will be doing packet captures to demonstrate problems. Right? How do you understand that? So that will come right as the last 2 days. We'll be basically walking through all of the topics. So it will be IPsec, interface level problems. Right? We'll talk about routing issues. Right? If you have a routing problem, your neighborship is not coming up, or your packet is getting forwarded via a different path than what you expect. Right? Or because of no route, you don't see any sessions on the firewall. How do you deal with that? Right? Then we will talk about different types of logs, right, and reports on the firewall. And finally, the global protect and basics. So any problem with global protect, that means user is unable to connect to global protect, right? They are complaining about latency. Home user connected via remote access VPN is complaining that internet is too slow. How do you identify that? How do you troubleshoot and fix it, right? All of that we'll be covering in this session. Then NAT policies, right? Basic policy evaluation. So your traffic is hitting the wrong policy, wrong NAT security policy. Traffic is not being decrypted, right? Or authentication policy is not working as expected, right? How do you test the policy? All of that. And the final components is basically the HA part. This is it does not require a different session, right? Because this will be covering over the HA session itself, right? Because it's very straightforward. So this is what we're going to cover. So the last 2 days is basically troubleshooting, right? And we don't have a specific end date as such, right? It depends on what is the pace that we're going forward. But ideally, the timeline is 1 month, right? With all weekday sessions, right? And typically 2 hours is what I would ideally say, right? Per day we would be spending, right? Any questions on the curriculum as such?
Yeah, hello.
Yeah, go ahead.
Yeah, Akash this side. I want to talk about the lab part. So are you going to provide us like OVF file, or we can access on the website? So that's my concern.
The OVF files I would be sharing, but we do have the BRAC support. So I think Gaurav, you can say about that, right? So
Yeah, so guys, the person is enrolling for the program, so he'll getting access to our server so that in 24/7 he can access our lab. However, if you need our images and all, you'll get it. If you want to set up a lab on your own laptop, you can. But most of the people are using our own server. We have a setup for that through EVNG.
Right. So we have dedicated servers, right, for networking. So that is used typically, right? You can host your firewall, right? I mean, I can share all the images. That is fine. The only problem being it eats up a lot of RAM. So, right, typically without 16 GB RAM, you cannot even at least 8-9 GB RAM you have to give for a firewall itself. So
yes, for single firewall. So
right.
if you'll see our topologies and all, that is, there are, you can see 4 firewalls in one topology. So if you want to run that particular topology in your own laptop, at least minimum 32 or 62 or 64 GB RAM is required, and nobody is taking that kind of high configuration laptop. So just to kill that issues, guys, we have our own servers. You can access, you can do whatever 24/7 you can access the lab. There is no limitation.
Okay, and yeah, one more thing about in theory part, you are talking about the Panorama. Is it like the smart console in Checkpoint? Is it similar to that?
Pretty much, I would say, but it is here, right? It is, I would say, right? Just assume that you have 500 firewalls for a company, and the global SOC team wants to make configuration changes on multiple of these. Typically, it involves going right to the management IP of each and every firewall. Instead of that, you have a centralized control, right? You go to the Panorama, you can make changes from there and push it. So you have a centralized point to do configuration management for all connected firewalls. You can push updates. You can push dynamic updates. You can even get directly access the firewall without even going to the firewall GUI or using the IP. From the Panorama itself, you can do a reverse connection as well. So it is a little bit more advanced. This is I would say in the industry currently, Palo Alto is having that edge on the Panorama device, right? Because I don't think other vendors have a similar solution, right, as advanced as Panorama, right? Why? Because it can act as a centralized config management portal. Also, it can act as a centralized logging perspective, right? That means a centralized logging as well, and other additional functionalities that we'll talk about.
Okay, thank you.
All right. Okay.
Hi, Kevin. Sorry, I joined a little late, but I'm not sure whether this has been already covered or not.
Mhm.
But with this course, what is the certification we can target? Like, is it like PC, an SA or SE?
It's PC and SE level that we are training
SE.
on this. Yeah. So
SE,
network
right.
security
Okay.
engineer. Yeah.
Okay, thank you. Yeah.
Okay. Any other questions, guys? Okay. Right. So we'll go to whiteboard session right now, and then we'll start off with the demo, right? Right.
And one more question, Kevin, before you start.
Mhm.
Sorry. What will be the duration of this course? How long it's going to be? Because this is like weekday sessions, right? So overall, how many hours are we covering for this session?
So I would say we would need around 35 to 40 hours, right? If you talk
Okay.
about in hours. So typically I take about 1 month, right? 5 days a
Okay.
week to complete it. But
Okay.
it can be little flexible, right? Here or there, it's fine. We don't have a strict deadline,
Thank you.
but yeah.
Okay. Thank you. Thank you.
Perfect. All right. Okay, so if there are no questions, right, I'll get started off, right? So this demo session, right, we'll be just walking through different types of interfaces, right, that Palo Alto is offering. So in PA, right, in PA firewalls, right, there are different types of interfaces, right, types that the firewall is offering. So the firewall comes in different models, right? Depending on the model, the number of ports will differ, right? It can be 4 port, it can be 8 port, 16 port, right? Depends on how much money you're ready to spend. If it's a VM, right, the firewall also comes in a VM perspective. That means you can download the OVA file or deploy this on a VMware or a AWS or Azure instance as well. So if it's a VM, right, you just need to get the right licensing to get the right number of ports and all, right? So all these ports of the firewall, right? So when I say ports, there are some functional differences, right? There is something known as a management port, right? Which all devices, right? All L3 devices have to basically manage it. So this is the L3 interface, which using whose IPs you will be SSHing or telnetting into or accessing the GUI, right? Or to manage the device. It's the same here also, right? You have a management interface, right? You also have a console interface, right? That means if nothing of this is working, you can plug in a serial cable and get the console access as well. But we are interested in the other ports, right? The ports that is handling data, right? Traffic from the internal network. So we are going to talk about different types of interface types. So the most common or widely used interface type is layer 3, right? Which you all know, right? Layer 3 interface, right? Works on what? IP layer, right? So basically it is working as a the firewall at this point with the layer 3 interface is capable of routing, right? This packet. So this interface comes with an IP, right? You have to assign a zone, right? So this is a zone-based firewall. Palo Alto is a zone-based firewall. That means if you want to allow a traffic that is coming through E1 bar 1 and exiting out through E1 bar 2, right? All interfaces, right, will be basically given a zone, right? Zone is nothing in Cisco, right? You would give a security level, right? And you call a name, right? Inside, outside. Similar to that, right? You can give a zone name attached to the interface. So let me call it trust, right? Trust network here. And this is untrust. So how do you do access control? I would create a security policy and I would say, hey, allow traffic to flow from trust to untrust, right? For port 80, or let's say I would say SSL traffic is allowed to flow, right? SSL and let's say HTTP traffic is allowed to flow from trust to untrust. That would allow all kinds of web traffic to go from the trust network, which is coming through E1 bar 1 to exit out of E1 bar. So there is a zone attached to each interface, right? So when you configure a layer 3 interface, you need to have a zone. So typically, right, trust, untrust, DMZ, right? Common namings that you would see. And you will also have something known as a virtual router, right? This is nothing but the routing domain, right? That means you can, the firewall basically has a single routing domain. That means a single route table, right? Or a routing logic. So all the routes are learned, are kept in a single table, and all packets coming through any interface goes through that logic, right? Or a routing logic will have a RIB and a FIB. So RIB stands for routing information base, and FIB stands for forwarding information base. So all routes, you might be learning 10,000 routes, right? Or let's say 1,000 routes from different protocols, right? Static routing, OSPF, right? BGP, all of that. But out of these 1,000 routes, what are the best routes, right? There might be redundant routes. So based on the administrative distance, AD, and the route metric and all, right? The firewall will select the best route, and those best routes will be added to the FIB table, or forwarding information base. So the FIB table is what is used to forward traffic, right? So when a packet comes to the firewall is looking into the FIB table and see what is the best route to reach that destination. Okay, it is E1 bar 3, and hence it is sent out through this interface, right? So by default, when you get a PA firewall, it comes with a default virtual router. The name itself is default, right? And typically customers, right, use that. You can also rename it. That's also fine. The idea here is, in some scenarios, right, when you have a dual ISP, that means you have two internet connections, right? One, let's say from Tata, right, and one from Airtel, let's say, right? And you want to have redundancy. Right, in case if Tata goes down, you need to have traffic routed through the secondary ISP connection. In that cases, you would need to split your routing domain, right? You would need to have separate set of routing for, right, ISP1 and ISP2. For that, you would, right, need to create different virtual routers, right, and assign it to interfaces. So let's say, right, I call two virtual routers, VR1 and VR2, right? So if I have one E1 bar 1 connected here, E1 bar 2 connected to VR2, right? And E1 bar 3 connected to Tata, E1 bar 4 connected to Airtel. So the idea is that, right, any packet coming through E1 bar 1 will look into the VR1 FIB table, forwarding base, to see how it can exit out, right? Whereas any packet coming inside through E1 bar 2 will look into the VR2 FIB, right? So basically, you're splitting the routing domain into two. So there will be two sets of, right? For VR1, there will be a RIB and FIB. Similarly, VR2, right? You will have a RIB and FIB. And right, it goes without saying that you can always send packets between VRs. That means, let's say, right, your Tata went down. Ideally, the default route might be towards Tata, your primary ISP. Something happened to your internet provider, it went down. So you would have you can add a route basically which tells, hey, all traffic towards the internet should go to VR2. So the packet will just jump from VR1 to VR2. And in VR2 FIB, I will have a default route already saying that all traffic should go via Airtel, right? And it will go out, right? So that's basically a virtual router. It's nothing but splitting the entire routing domain, right, into multiple small routing. So you have your typical firewall is basically acting as a single router with one routing logic. You can divide it into different small routers, right? And each routers will have associated interfaces, and you can make it work, right? And this is used in multiple use cases, right? The most commonly used is with, right, dual or tertiary ISP setups and all, right? We'll be discussing this when we talk about routing scenario, right? And we'll show you, right, with a real life example how you would be doing it, right? So for a layer 3 interface, right, you need an IP, you need a zone, you need a virtual router. So what this means is, right, in a network, you have a firewall, you have a layer 3 interface, right? Let's say E1 bar 1, I put in layer 3, right? I'll connect the router. This is the core router. So on the firewall, I'll give E1 bar 1 the IP as, let's say 10.0.0.1, right? And let's say this router IP is 10.0.0.5, right? And behind this router, there's a switch, right? Multiple layers of switch, right? So this is the core layer, this is the access layer, and finally, a lot of computers connected to it, right? So all of this traffic that the user initiates, right, comes through the switch, right, access layer switch to the distribution, right, to the core router, and basically, right, on the router is forwarding everything towards internet to the firewall. Once so the next hop or the default gateway on the router, right, the default route on the router will be pointed to this IP, which is the IP that you have on the layer 3 interface. And right, the firewall will basically do the route lookup, do the security policy evaluation, everything. And right, if there are no threats, no blockages and all, it will allow it, right? So this is the standard deployment method that, right, most of the customers use. Why? Because right, firewall is typically need to be deployed in layer 3 mode to basically have all functionality. If you want to use entire feature set of Palo Alto, layer 3 is the best mode that they suggest, right? Whereas when you move to layer 2 and all, there are some limitations, right, with certain features and all, right, which does not work so well. So layer 3 is nothing but, right, firewall is capable of, or interfaces are having a layer 3 IP, right, and routing logic will be applied based on that. Now, the other interface is nothing but a layer 2 interface, right? Here, the idea is you have a firewall, right, and you want to connect it to a switch, a layer 2 switch, right? Let's say you have multiple switches here, right? Let's say this is handling VLAN 10, 20, and 30, right? So these are all trunk ports, right? All this you have, let's say 10, 30, 40, 4 VLANs inside your network, right? Different VLANs. And right, you can basically connect your firewall with a single VLAN. That means a single VLAN also, right? In the layer 2 mode, right? You don't have an IP anymore, right? You can have a VLAN information, right? You don't have any IP as such. You will have a zone, right? So you basically select the VLAN, right? You connect to your firewall interface, right? In layer 2 mode. This is in L2 mode. Let's say E1 bar 1 in L2 mode, right? And you can set it up as we add a VLAN tag also, right? If you're planning to send only VLAN 10 traffic here, let's say this is an access port and you're only sending VLAN 10, you can do that, right? So VLAN 20, I can set up another interface. So inter VLAN switching can happen right here. Sorry, inter VLAN is a different scenario. We'll come, that is the next part. So basically different VLAN traffic you're getting on the firewall, and based on that, right, if you have a L3 interface here, you can set it up and forward the traffic outside. This is highly unlikely that customers would deploy like this. Or the other use cases in the intranet itself, in the customer, the firewall is not facing internet. Instead, it is going or inspecting internal traffic of a company, right? You have switch here, which is connected, right, to an L2 port, similarly another switch. So between two different branches through an MPLS connection, all traffic going through. So this is not a perimeter firewall, instead an internal firewall inspecting branch to branch traffic, right, over a private circuit, right? In such scenarios also a layer 2 mode can be used, right? Typically layer 2 is not suggested by because certain features like right, captive portal and all, right, would need an IP on the firewall interface, right? So it's very hard. You would see a certificate error and all, right, when you use a layer 2 mode deployment. Right? So typically not suggested. L3 is always suggested, right? Just a question here, right? I think people who are already aware about CCNA routing switching, you should know, right? You should have heard about router on a stick config, right? So why do we use a router on a stick? What is the aim?
To enable communication between two different VLANs.
Correct, right? Inter-VLAN switching, right?
Right.
So you have an L2 switch and you have multiple VLANs and they need to communicate with each other, right? Different VLANs, they want to talk to each other. And how do you enable that? So in Palo Alto, also in the Layer 3 deployment, you can do that as well, right? That means you can basically set up, right? Let's say this E1 bar 1 is in Layer 3 mode, right? I'll modify this as a switch, L2 switch. So this will be a trunk interface through which you will be sending everything. And this E1 bar 1 port, you will configure it as a Layer 3 interface, L3 interface itself, but you will not give any IP, right, or zone, nothing, right? You will just create an L3 interface. What you will do is you can create something known as a sub interface, right? Similar to what you would do on any router, right? You connect a trunk port to a physical port of a router and create sub interface, right? Virtual interfaces. So I'll create E1 bar 1 dot 10, right? This will be my right VLAN 10 gateway. So I can give an IP 10.0.0.1, right? I can create another sub interface 1.1.20 will handle my VLAN 20 traffic. So 20.1, right? So all I need on the firewall is, right, some routing logic. So once I set this up, all of this will be connected routes. So if a packet comes, right, from 20.network to 10. Right, the gateway is, right, coming to 20.1, which is the sub interface IP. Then based on the routing that is there, right, it knows that, okay, if it wants to go to 10.0 network, yeah, this is the sub interface that it should go through. So packet will just come through the trunk, right? It will just come through the trunk, right? For the firewall, it will be incoming from E1 bar 1.20, and then it will go out back to the trunk via E1 bar 1.10, right? Normal router on a stick configuration also can be achieved. So Palo Alto do support sub interface, right, or virtual interfaces, right? So from a Layer 3 deployment perspective as such, right? Okay. Now moving on, right? So Layer 3, Layer 2, right, connecting to a switching environment. Third, or more interesting part, right, which all other vendors are typically looking forward to is, right, or let me just wipe this, right? The other mode, right, one of the other mode is vWire, right? vWire deployment, or we call it virtual wire, right? Virtual wire, right? It comes with different, some people call it bump in the wire, right? Different names. So basically this is a transparent mode of deploying, right? Very specifically used in two scenarios. One is in proof of concept or a POC or a POV scenario. That means, right, you already have a, let's say, checkpoint firewall or Cisco ASA, and you want to try out Palo Alto, right, without making any major network changes, right? You want to evaluate Palo Alto firewall and see if that is good, and then decide to buy it. So typically Palo Alto sales team does this. They deploy this in a vWire mode in a customer environment. So let's try to visualize that, right? You have the same setup, right? A router, right? A switch and multiple, right, users behind it. This router, right, is connected, right, to, let's say, your Cisco ASA. There are two ways of implementing it, right? The most common being, you can, okay, I'm going to call this one as ASA, right? And what they will do is, between the ASA and the ISP router, right, or the default gateway, they will just plug the cable coming from the ASA to the firewall E1 bar 1, right? This is the PA firewall, and from E1 bar 2, they will connect it to the router. So let's say the IP here is 134.0.0.1. The IP here is 134.0.0.5, right? Here, I can call E1 bar 1, right, in an E1 bar 1 and 1 bar 2 in vWire mode, right? So in vWire, basically it acts as a pair. That means you cannot create a single vWire interface. It's always comes as a pair, right? when you create a vWire pair, you will have two interfaces. The idea being that any packets that come through one interface will go out of the other. It's a hollow end pipe. You can assume like this, right? One interface will be here, the other. So anything that comes through here will go out here. Anything that comes through here, right, will go out here. Right? It's a vWire pair. Basically means two interfaces come together, and it will act like a virtual wire. The important part here is there is no IP, right, for this interface. That means you don't have to give any IP. There, it will not participate in any kind of ARP learning. Right? We will not be, this device will not be sending out any ARP request. No, I mean, it does not have an IP. So basically this device will be transparent in the network. When you do a trace route, right, this hop itself will not be visible, right? Because it does not even have, the other systems will not even see this, right? The ASA will think it is directly connected to the ISP router. The ISP router will think it's connected to the ASA, but there is a device in between, right? So what it basically does is anything that comes through E1 bar 1, right? You can set up zones for these, right? So I'll call E1 bar 1 as part of trust, right? And E1 bar 2 part of untrust, and I'll set up policies, right? But typically what customers do is, right,